Welcome everyone, and thank you for joining us. I'm Brenda Dittinger from BIOPAC, and I'll be your moderator on today's webinar, Biofeedback Theory, Techniques, and Tools for Research. Today's webinar is being recorded, and we'll send each of you a link once that recording is processed. During the webinar, if you have questions, please submit them through the GoToWebinar control panel. That's how you communicate with me. I have some helpers in the background who will be answering questions, and I'll pass as many questions on as I can to our presenters. Now, on to our presenters. I'm excited to introduce our experts today. We have Dr. Sanjay Sood. He has his PhD from All India Institute of Medical Sciences, New Delhi, and he has over 32 years of experience working with a diverse medical student population as a physiology teacher and researcher. He is currently a consultant with BIOPAC. Welcome, Sanjay.
Hi, Brenda.
We also have Alex Dimoff. He is a product expert and the head of sales for Europe. He has taught over 125 workshops on the topic of physiological data acquisition and analysis, and has been with BIOPAC for 20 years. While at UC Santa Barbara, he was an instructor for the Advanced Training Institute for Virtual Reality and Social Psychology. Welcome, Alex.
Welcome, everyone.
All right, Alex, let's start with you. I'm going to make you presenter.
All right.
So
Okay.
here,
Go for it.
So here what we are doing is we are giving a live demonstration. So Alex is tied up, so he won't be able to communicate, speak. So I'm just trying to fill that up. What he has done is he's tied respiratory strap over his chest to see the respiratory movements, and the target would be to keep the respiratory rate around six breaths per minute. And if you see, here is a gauge which is shown, and he'll be breathing, trying to keep the respiratory rate within 6 breaths per minute. So this all is possible in AcqKnowledge, and today that's what we are going to demonstrate to you, that what all potential applications are there and how we can exploit them while recording biofeedback. So Brenda, can I show my slides? Thank you.
Yep, I just made you presenter.
Yeah, thank you, Brenda. So before I start the webinar further, let me give you a little background information about BIOPAC. We develop state-of-the-art, high-quality scientific tools so that you can record physiological signals anytime, anywhere on any subjects. We have been in business for last 39 years, and to our credibility, you will be amazed to know that 99% of the top universities in the world use our gadgets. And not only that, even some clinical equipment manufacturing companies and pharmaceutical companies use our equipment as a gold standard to validate their tools. So far, BIOPAC has been cited around more than 55,000 times. And you see, BIOPAC offers both research and teaching tools. And for research, it's MP200 system, which is ACQ cloud-based, and it is the hub of recording. It can record up to 16 channels, analog channels, can record digital and calculation channels as well. It comes as a modular unit, and it's supplied with AcqKnowledge software. And there are many biosignals which we can record. You name it and we have it. So here, if you see, there are small amplifier, we call them smart amplifier. So this is they are very robust in the sense that they pick up signals noise free. They're located near the recording sites, and BIOPAC also offers wireless recordings. So we call it bionomedics. So here is the receiver with the antenna and also a bionomedics module which will be attached to the subject. If you're interested in outfield research, on the go research, you can use loggers. So they are tied to the bionomedics recording systems, and later on you can go to the lab and analyze your signals. So in a nutshell, if I have to say that BIOPAC offers various multimodal data acquisition scenarios, starting from eye tracking, non-invasive blood pressure measurement, researching bioharness and brain-computer interface with AI enabled. And also we have fNIRS, that is functional near-infrared imaging from forehead or from whole of the head, along with EEG. So these signals can be recorded wired or wireless. Then we have also EEG solutions, and we also provide face recognition software. And of course, we have a full range of virtual reality scenarios where you can record various signals, and biosignals create scenarios, and they're all in virtual setup. The other device is for teaching primarily. It is a 4-channel universal MP30 system, 36 arts system. It is used both for teaching and research. It comes with various sensors, and BioPAC does offers more than 40 research field possibilities, starting from cardiovascular to respiratory, muscular, autonomic, neurophysiology, virtual reality, and many others. We also have many options for giving sensory stimuli, from haptic to thermal stimulation, from electrical stimulation, auditory and visual, and of course we have also scent delivery system for olfactory stimulation. Coming to the webinar, today we are going to discuss theory, techniques, and tools for doing biofeedback research. At the very outset, I like to emphasize that our tools are primarily meant for research and teaching and not for clinical usage. So what we will do is, in the beginning, I'll give you a brief overview of biofeedback theory. Then I'll share with you some demonstrations in terms of auditory and visual visualizations. And then my colleague Alex will come and he'll demonstrate to you various other possibilities which are there with AcqKnowledge software. You see, biofeedback, the term was first coined by Miller. He says that it's a real-time psychophysiological mirror. So the idea was that seeing is believing, that when thoughts and emotions are there, they affect your body. But before that, the concept was that autonomic functions or visceral functions cannot be influenced at all by volition. But he showed that with operant conditioning, one can change various autonomic functions, and that is the basis of with training. What happened that one learns to control various um, one learns to exert voluntary control on various involuntary body processes, like maybe heart rate, respiration, or EMG, and also in terms of neuro biofeedback. That is, with various interventions, one can change the status. So means uh, the subject is given feedback when he's aroused or when he's relaxed, and then accordingly he can change his behavior. So the applications for biofeedback are many, like in psychophysiological research, attention, cognitive enhancement, HRB, biofeedback, physical rehabilitation, meditation and mindfulness, sports training, emotional regulation, and many more. So let me give you the various types of biofeedbacks which are used. So generally, one commonly used is for muscle contraction. So this is for rehabilitation after maybe some stroke or some muscle atrophy. So the subject is given feedback about his muscles contractions. So he gets a visual input in terms of maybe visual, auditory, and then he improves on that. Similarly, breathing is another type of biofeedback where slow breathing improves relaxation. So you record heart rate or electrodermal activity and gives which gives feedback to the subject. So gradually with training, the subject is able to control such functions. Heart rate is another way, and electrodermal activity another way of doing biofeedback studies. Neurobiofeedback is another very interesting subject where the subject, when he's relaxed, there is alpha buildup, and the subject is given feedback, visual or auditory, to maintain that state of mind. So this is being used for meditation or mindfulness techniques, and of course temperature. And there are many other ways that you can study biofeedback. Now, just to give you an overview of what BIOPAC offers for doing such studies. Now, we have many options. So, depending on the researcher, the kind of setup he's interested in, the kind of applications he's interested in, he can choose and accordingly plan his research. So the first thing would be to pick up a biosignal, and that biosignal will be through amplifiers, wired or wireless, will be fed to MP200, or you can also use MP36. So I'll be using MP36 for my part of demonstration. And then after the signals are filtered, they are being processed by AcqKnowledge software and analyzed, and then these signals are fed to the subject, maybe in terms of auditory or visual visualizations. So the subject gets some feedback, and then with training he improves on his response. At the same time, in scenarios where the doctor is using this technique, or a trainer is using these techniques, there is a parallel monitor where the observer is receiving all these inputs and he also can respond. So this is basically a overview of the biopack biofeedback setup. And now I'll hand over to Brenda for poll one.
Great. Thank you, Sanjay. I'll go ahead and launch this first poll. And while you are all are answering the poll, I will just remind everybody that you can ask questions through the GoToWebinar control panel. We'll get to those questions as soon as we can, or we'll try to handle some of them at the end. And then also I have Fraser on the back end helping with answer questions. So you might get a question right away, an answer to your question right away. All right, let's take a look at these poll results here. Looks like, ooh, tied. Oh, well, almost tied. A little bit more intermediate. A lot of people are beginner with no experience. A lot of people with intermediate less than a year, and only 8 and 5% of proficient and expert and advanced user. So thank you all for participating, and we'll go back to you, Sanjay.
Thank you, Brenda. So what we have decided now is to show you various possibilities with AcqKnowledge. As I told you before, that MP200 and MP36 comes with a very powerful software which we call AcqKnowledge. And there are many inbuilt tools in AcqKnowledge which can help you to record various biofeedback applications. Now we have just chosen the simplest ones, the basic ones, but depending on your applications, you can choose and uh, exploit the various options which are there in AcqKnowledge. So what I'll be doing is I'll be using MP36. This is MP36, and channel 1 I'm connected to hand dynamometer, and I've chosen this because it gives me freedom to operate, because I'm also speaking. But one can also use EMG to pick up EMG. But what I'm doing instead is I'm using hand dynamometer to see the clench force. So during this session, what I'll be showing you is that how we can use various tools in AcqKnowledge. So there are many ways that the subject gets feedback, and especially it's true for biofeedback, that whenever a subject is performing, he should get feedback. So, so either we can display the text values of his action, whatever he's doing. Suppose he's uh, clench forcing, so how much strength is generated, how much force is generated, so he'll get the value, or his respiratory rate or heart rate will be displayed, so that gives him some input. Then we can also create scenarios where there are input values which are shown as a bar, and the subject can directly visualize them and perform accordingly. Other one could be the gauge. So there will be some specific areas in the gauge where the subject has to, like Alex showed in the beginning, that the respiratory rate should be within 6 breaths per minute. So there was area marked. So the subject tries to be within those boundaries. And then we can also create various target patterns, lines in various channels. So whenever the subject crosses those lines, you get visual or auditory feedback, and we can use them to reward or kind of give him a negative feedback about his performance. And of course, for those channels, when the subject is crossing those lines, especially those overlay channels where there are lines created for 100%, 150%. If the subject is crossing 100%, he gets sound feedback. So I'll be demonstrating one by one how it is done. So let me open AcqKnowledge first. Here is the AcqKnowledge software, and the equipment I'm using here, if you see, is MP36. So again, I'll try to emphasize that I've chosen clench force as an example, so that's easy to demonstrate to the audience. But you can use any of other signals, maybe heart rate, HRV, EMG, EDA, and plan your experiments. Idea is to show you the possibilities which are there with AcqKnowledge. Now, the first thing is the equipment is connected to the laptop MP36, and the hand dynamometer is connected to channel 1 of MP36. Now, what we will do is first thing is to see if there is any offset in the recording. So I'll start recording. I'll so there is no channel as yet selected. So I need to go to setup data acquisition here. And if you see, I select channel 1, and here is the clench force. The hand dynamometer I have is SS25LB in kg. So I'll select that and close it. Now let me record again. So it will automatically calibrate. The equipment calibrates the hand dynamometer. So I press calibrate, and you see here at the bottom you'll find that there is no offset and it's automatically calibrated. So this is the first step. Now, to give a better visualization to the subject, it's better that we convert all his efforts into percentage. So in order to do that, what I'll do is I'll record 3 maximal voluntary contractions, MVCs, and then we know exactly, note down the maximum value achieved. So let me record that, start. So here is the first clench, second, and third. I'll stop. So I have 3 recordings. Now I'll find out the maximal voluntary contractions in terms of kg. So here, if you see, there are a lot of menus here. So I'll pick up the first one, select channel 1, and maximum value. Others are switched off. So let me find out how much is the maximal contraction. So it's around 37 kg. So if I divide 100, let me take out the calculator here. So if 100 is divided by 37, the factor is around 2.7. So I note it down. Now what I'll do is I'll create another calculation channel. Here I go and go into the setup data acquisitions and go for a calculation channel. So that will be maths. So here I have another channel which is another channel which is maths channel. So here I multiply this with 2.7. So this is how you fill in the values. So source 1 is k constant, operation is multiplication, source is channel 1, the factor which is to be multiplied with this 2.7. So let's close everything, and then you need to change the values here. Okay, so I'll record again. So you'll have 2 channels now. So there will be one channel. So there are 2 channels now. If you see here, one is showing, the lower one, if you see, is showing the values in percentage. So that will be a good feedback to the subject. So this is the first step which has been done. Let's stop here. Now let's explore what else we can do with the AcqKnowledge to give good biofeedback to the subjects. So here, now what I'll do is, here is another set of recordings. So what I'll show you now is that how can you add values, and how can you display gauge and also input values. So here, if I record, if you see on the right side at the top, you're finding whenever I'm pressing the hand dynamometer, there are values which are coming. Okay, so this is in percentage. So it's very easy to initiate. So what you do is you right click on this side of the window, and you'll find this window coming here. If you click show textual value display, so you'll find the values will be displayed here. So this will help to give some feedback to the subject to improve on his previous performance. This is one way you can do it. The other one is you go to MP36 button here, then set up data acquisition. Now what we'll do is now is create calculation channels. So let me create some calculation channels here. So what we do is we have created 2 calculation channels. Okay, before that, let me also cover the other aspects, that is input values. So you press show input values here. This will open up a window here on the left side, which is you can have many options. So here you can either show channel numbers, show units, show labels, show minimum and maximum, show values. So by this on the side, when the subject is performing, he get immediate feedback. So this will be a good visualization for the subject to get immediate feedback about his performance. Then the other aspect is creating a gauge. That one is very simple. You go to MP36 drop down menu, go to the show gauge, and here you'll find insert. So this I created myself, this picture I created in PowerPoint, imported a gauge, and then marked the areas of my interest. So in order to program this gauge, you need to right click over this, go to preferences. So you can change the color of the background. Then you can also change the thickness of the needle, which will move, this black one. So I've kept it at maximum thickness. Then another thing is how much is the total mapping. So we are interested in 0 to 120%. So I have marked it from 0 to 120, and then also create a band. Now the study we are going to do today is on this biofeedback is we'll ask the subject to perform, give a maximum voluntary contraction, note it down, without looking at the monitor or without any auditory or visual feedback. And then later on, we'll show him the feedback, visual, auditory, and then let him perform. So what we'll do is we have marked a range band that whenever he crosses 100 and 120, so the needle will reach here and there will also be sound generated. So now let's record this. Let me adjust the windows, and here I have adjusted the windows. Now let me clench again, start. Okay, so here it is. So I've achieved 100% and gone beyond even. So this is the feedback which is coming to the subject. So this is a very simple way of doing. Now we can add sounds whenever he crosses a line, a predefined uh, signal value. So there will be a sound input coming to the subject. Now how to create that? So let me close these windows one by one. So here, if you see, I have created the first channel is clench force, and then I have created two expression channels here. These are two expression channels. Now let's see how to create these expression channels. Go to MP36 drop down menu, set up data acquisition. Once you reach here, you click here, C2 and C3 are the channels which I have selected. So these two channels are the expression channels. So you can pick up from this drop down menu where there are many options. So you pick up expression channels, and now in the expression channels, if you go to setup, what I've done is I have created a preset value of 100 in one of the channels, and in the other one I have created 120. So this is a hypothetical scenario. Researchers can use any of the options which are available, or depending on their research paradigm, they can create such expressions. So this is how these expression lines appear. So when I start the clench force, so you see what's happening is channel 1 is showing the force generated. in percentage, whereas the other two channels are showing lines at 100 and 120. Now the simple trick is if you superimpose them like this, so now what will happen is when you press the button, the subject gets a feedback when he's crossing his 100% or when he's crossing his 120%. So this is how you can use these expression lines, these channels, to give feedback to the visual feedback to the subject. Now, the next one is how to use sound feedback along with these expression lines. When the subject is crossing 100%, there should be a sound generated. When he's crossing 120%, there'll be a sound feedback coming to the subject. It's again very simple. So what I've done is, as I told you before, there are two expression channels created, and then you go to drop down menu from MP36R and set up data acquisition. Now what you do is you create another expression. So the expression is, if you see the setup, it's a logic function. If the variable, whatever it is, it could be heart rate, it could be respiratory rate, it could be EDA, it could be EEG, waves, right? Alpha, beta, whatever you decide. So in this scenario, what I have done is created a formula wherein if the value is below 100, then there will be no sound played. If it is more than 100 and less than 120, there will be 880 hertz of sound. And if it is more than 120, the sound will be 1200 hertz. So this is how this formula is created, and it's we can also share this. And if you have any specific queries how to generate specific to your research paradigm, you please contact our local salesperson, or you write us, so we'll be able to help you in that scenario. Now once this is done, at the same time, if you see here, there are options. So you need to select the sound feedback. So it's enabled here. You pick up output sampling rate and also the channel for expressions. So this is all set now. So now if you play, so I have not superimposed the impulse, the channels. So if you play again, you'll find that there will be a sound displayed. I mean, a sound generated whenever you're crossing 100%. So if you overlap the channels and try to create clench force, let's say you're not able to cross 100%, there'll be no sound played. Then if you cross 100%, so there'll be around 800 hertz of sound audible. And if you cross 120, there'll be a different sound which will be audible. So you can program, plan as per your paradigm, exploit these options which are available with AcqKnowledge software. So the paradigm would be for this biofeedback recording that I'll record a 5-second baseline. Then I'll record maximum voluntary contraction for 5 seconds. I mean, a block of 5 seconds. Each maximum voluntary contraction will be for 2 seconds. In a way, I'll record 3 in each session. And then I will be giving feedback to the subject, maybe in terms of the gauge or text display or input values, and then see what happens to the performance of the subject. So let's start. So the first one is the baseline recording for let's say 5 seconds to cut short the time. And then the next one will be the subject will not be getting any input, any feedback, auditory or visual, and then he'll record his maximum contraction. So here it is. And the last one would be that the subject would be shown, let's say here in this scenario, the gauge. So he'll get his feedback from the gauge. and then he'll perform again. So let me start again. So he'll be looking at the window. He'll get both visual and auditory feedback. So he's asked to clench 3 times. So this is in brief the setup for doing EMG biofeedback. And as you have seen, AcqKnowledge offers so many options to plan your experiments, and then accordingly design various ways, the way you want them to be. Like for example, if you're interested in neurofeedback, you can use EEG as a signal. If you're interested in relaxation, meditation, mindfulness, you can use heart rate and EDA, and there are so many other ways. So this is it from my side, Brenda. Now let's go for poll 2. Thank you.
Okay, great. Thanks so much, Sanjay. I'll go ahead and launch poll number 2, and then I do have one question from the audience. Yasmin, you asked about is this webinar useful for people using the MP150 system or the MP160 system? So I'll let you guys answer that.
Yeah, so all our systems like MP36, MP30, MP160, MP200. So you can use any of those equipments, and the AcqKnowledge is common to all. So you can record these biofeedback sessions using any of these tools you have.
Okay, and then we had I don't know how to say this name, Setsuri Cesari asked a question about finding documentation. I just thought I would share with the audience that the software guide does include information about all the functionality and the sound functionality that Sanjay showed. And also we do have scripts and different things on our website for resources for you all. Okay, I'm going to go ahead and end the poll. Looks like the most popular signal is heart rate, and followed by respiration, and then EMG, fNIRS, and EEG. Oh, actually EE. So it goes. Hang on. So heart rate, respiration, EEG, EMG, and then what was the last one? fNIRS. So here we go.
All right. Okay. Thanks, Sanjay, for the great overview. And what I want to show next is I want to first point out some things about AcqKnowledge's capability. And already you saw quite a few things that can happen via what we call calculation channels in AcqKnowledge. That's a really important point because you have all this data that are coming in, which could be EEG, EMG, skin conductance, heart rate, etc. But that's just raw data. And then AcqKnowledge has the capability in real time to do some processing. So we can do some basic filtering, and we'll just jump into the software here. And when we set up our channels, let me just, yeah, I'll just escape out of the presentation so I don't have any conflicts with my screen. So we can come over here, select the channel, and actually this is how we have set this one up right here using a filter. And these filters can be low pass, high pass, band pass, etc. So we can condition the signal, we can remove noise, we can remove some offset. So this is one thing that we can do in real time. Now, next thing we can do is we can take that data and derive respiration rate, heart rate, our interval calculation. That's exactly what I've done here. So using the preset for respiration rate, and then going inside here and choosing how I want to do it. It can be based on a specific signal type, so respiration rate, but it can actually be doing ECG or heart rate from pulse or ECG, etc. So we just choose where the calculation is coming from. So the calculation can be coming from a channel that's already filtered, like in this case. So we can say, oh, it should be coming from the filtered channel. And then we apply our calculation. Okay. Furthermore, we can do things like threshold detection. So let's say we're recording skin conductance data and we want to detect a threshold or skin conductance response. Well, we can set that up also as a channel, and that will be right here under function, and we have a function called threshold. So we can say we have a threshold of 0.05 microsiemens and 0.051. So whenever we cross a threshold, then we are going to output essentially a 1 versus a 0. In addition, we can perform things like EMG integration. So I'm just going to come over here and look for EMG. I can filter the data, and then I can also perform some EMG integration, adjust my settings, etc. So we can be monitoring EMG activity and then integrate the EMG, maybe look for some level of activation, and then something happens, then some sort of feedback is provided to the user. We can also derive things like the different EEG bands, again, coming into the calculation channels. Now we just move over down here where we have the EEG filters. So we have alpha, beta, gamma, and so forth, right? So we can look at what's happening there, specifically related to alpha, for example. So a lot of computation can happen in real time in AcqKnowledge. You can have lots and lots of these channels, and you can make really complicated setups if you want. You can even do things like waveform math. So taking a channel and multiplying it, or doing something else like Sanjay showed, using so either waveform math where you do some transformations with the data, or using expression where you have access to a wide array of functions that can perform transformations on the data and calculate some derivative measure. And even more complicated than that, but really helping a lot with your biofeedback designs, is you can run what we call BIOPAC basic code. So here's an example of some BIOPAC basic code. So you can have some additional processing again happen to the data in real time. So for instance, and we're not going to show this now, you can do the calibration steps in an automated fashion. Okay, so all right, so that's just giving an idea about all this extra capability that is within the software. This is all happening in the software, and then the data, you either make something happen in AcqKnowledge, you provide some feedback like we've done right now, or you send the data elsewhere, and we'll discuss that. Another type of channel that's very important for biofeedback is what we call a control channel. Now, control channels allow us to send to set the state of the digital channels of the system either true or false. So basically 5 volts or 0 volts. So why is that important? Let's look at this scenario here. Let's say we're recording electrocardiogram data from the participant. Then we're applying some filtering as a calculation channel. Then we are calculating the heart rate, again as a calculation channel. And then this control channel can look at the data, and if the heart rate's above 100 beats per minute, then we'll output a signal on one of the digital channels. If yes, you will output a signal. If no, we will not output a signal. And then this STP100D module that you can get with the system, which has an isolated parallel port interface, can communicate this signal change via parallel port cable to a computer that can receive the data. So that can run some stimulus presentation software, maybe SuperLab or similar. So then based on the change in heart rate, this stimulus presentation software provides feedback to the participant. So in this scenario, AcqKnowledge is doing some processing on the data, making a decision, have we reached some sort of target state? If so, let's notify the external software that this has happened, and then the external software provides some kind of feedback. On top of that, we can have that software send a marker, an event marker, back into our software, again using those digital lines. So we can record that biofeedback intervention. So how do these channels work in the software? Well, let's come over here to the AcqKnowledge software and go to set update acquisition again. I'm going to disable this channel that I made. And here we have a control channel. Now the control channel has a source, and the source is going to be the respiration rate. I know I illustrated with heart rate, but let's use respiration rate because I'm currently instrumented with a respiration belt. And I can choose what channel I'm going to control. So I will control channel 8. The reason why I'm choosing channel 8 is sort of arbitrary in this particular case, but yeah, you can choose any one of the channels. So, and then you just have to make sure that it's a channel that will communicate with the hardware in question. And then we can see here what will be the logic. Whenever we are between 10 and 15 breaths per minute, we're going to get a pulse, basically. All right, so we reach a specific target respiration rate, there's going to be a pulse. So I'm going to do a quick recording where I will not speak for about 30 seconds so you can see what happens. So we can see here that I reached the threshold, okay, because the respiration rate went into that window between 10 and 15 breaths per minute. So now that control channel turned on. And then, once my respiration rate goes down again, the control channel will be turned off. Okay, so these control channels can communicate to external equipment what's happening, and then biofeedback can be provided. They can do other things though. So this STP-100D unit also has the capability to turn on and off equipment using these solid state relay drives. So again, we record the physiological signals from the participant. AcqKnowledge makes the decision based on what we provided as criteria to turn on or off specific digital channels. It has to be one of these channels, 0, 1, 2, or 3. So in AcqKnowledge, if we go to set update acquisition, we have to be controlling specifically one of the first channels here, okay, from D0 to D3. And what will happen then is we can hook up a device that can be turned on and off by these relay drives. It's just a BNC cable. So you could turn on a fan when the person gets too hot. You could turn on a light if they're getting anxious. You can play an external speaker if the heart rate reaches a certain level. You can even connect to an Arduino system, which I have also done, which can then do more complicated things. And then basically that's a form of biofeedback again. All right, now somewhat related to this again, we also have the capability in AcqKnowledge to provide electrical stimulation as a form of a biofeedback modality, right? So again, some physiological changes happening, changing heart rates, conductance response, etc. And then instead of playing a sound, we actually provide an electrical shock to the participant. Or one example could be you have a very small EMG activation during some rehabilitation experiment, but you can't really activate the muscle. So the moment we reach some sort of threshold of this EMG activation, we actually provide an additional electrical pulse to help the muscle along, right? So this kind of experiment can be conceptualized as sort of like biofeedback training experiment. So how do we operate all of this? Now, I have a separate recording file set up over here. Again, we go to setup data acquisition, and now we choose the stimulator option. So there are two different channels for electrical stimulation, 0 and 1, that the system controls, and we can define a custom waveform for electrical stimulation. So here I have defined a 1 millisecond pulse at 1 volt that will occur every 50 milliseconds, and it just keeps going forever. It's like output continuously. All right. In addition to that, of course, we have our channels. We have here an expression channel that's simply outputting a sine wave. So I'm going to pretend that this is the physiological signal. I'm not going to be connected to ECG or anything like that. So I'm actually going to use a simulation. Okay. And then we have a control channel again. And this control channel, if the sine wave value is between 0.8 and 2 volts, it will change the status of one of the digital channels. That's digital channel 6. Now, what that channel does is it greatly attenuates any output of the stimulator. So the default state of our stimulator is keep shocking the participant, basically, right? Keep delivering stimulation. But it's actually just going to be suppressed. So I'm going to hit start here. Top channel shows the stimulator output, and then the control channel is in the bottom. So only when we make this value equal to 0 are we allowing the stimulator to fire. So I'm going to stop this for a second, okay? So we can turn basically on and off the stimulator by these control channels in the AcqKnowledge software. So something happens of interest and criteria is met, and then we either stimulate or don't stimulate. Now, we can turn it off, on and off based on physiological signals and also based on a digital signal. But just keep in mind, some of this functionality will be available only on the NP200 and upcoming software releases. So that goes back to the previous question. Does everything work? Well, pretty much everything works the same, but like this is one example where some of the stimulation features are more advanced with the latest hardware. Then there's another way that you could control electrical stimulation as a modality for biofeedback. We have a programmable stimulation system. So the physiological state is analyzed in real time within the AcqKnowledge software or the control software, which could be ePrime, our VR system, and then the software sends instructions to our stimulator via this card over here to deliver or not deliver electrical stimulation. So that's now the decision making is not happening in AcqKnowledge, it's happening externally. And very important, if you are using electrical stimulation, we always recommend to record both current and voltage, and we have a kit that does that. So if you're getting into any form of electrical stimulation, please consult with our sales and tech staff so they can recommend the correct way of doing that. We also can use thermal stimulation as a feedback modality. So let's say that we're continuously monitoring heart rate and temperature. And then we have this device placed on the hand of the participant, which can deliver a sensation of heat or cold. And then if the subject successfully lowers their heart rate during a stressful task, we can deliver sort of a gentle warmth as a reinforcing cue, okay? So the AcqKnowledge software, using these control channels and calculation channels, can check, are both the heart rate and the temperature below their thresholds, and if so, turn on the thermostimulator. So basically the participant relaxed, hands a little bit cold, let's give them a reinforcing stimulus. But otherwise, we shut off the thermostimulator. So we can make these sort of control loops. We can also deliver sense as a biofeedback display modality, right? We have a scent delivery system that's modular. We can have up to 8 different scent modules that are then controlled either by AcqKnowledge software or by our VR system or third-party software. And the idea is we, again, monitor physiology. For instance, we figure out if the participant is relaxed. If they're not, nothing happens. But let's say they have a reduction in skin conductance, heart rate, or some other criteria, and then we have them smell the flowers. All right, so we deliver a smell of flowers, or really one of many different scents that we provide, or scents that you would insert in this chamber and deliver to the participant. So it's another modality. And these are just control pathways. We'll leave this in the presentation to be provided. That's a bit too technical to go into right now. We also have a haptic stimulator. So this device can be attached to the participant, and then there is a little pin that pushes against your skin, and you can set how far it can travel between 0 and 3 millimeters. That's a manual adjustment. But then using the very same stimulator window that we use for electrical stimulation, we can set up a haptic stimulus where between 0 and 1.5 newtons of force can be delivered. And then again, we can turn on and off this form of haptic stimulation based on the control channels, that same digital channel 6. So the default state will be to suppress the stimulator, and if a physiological state condition is met, the stimulator becomes active. So we can combine lots of feedback modalities. We can visualize with the gauge. We can release a scent via control channels or external equipment. We can turn on a fan via the relay drives. We can fire up the haptic stimulator. Let's go for our next poll, and then we'll go to the next section.
Okay, great. Thank you, Alex. I'll go ahead and launch this poll and just leave that poll slide up in the background there, if you don't mind. Okay, are you interested in performing experiments in VR and AR? And I have a quick question from Elamir, maybe. Is this the pulse pressure or heart sound sensor included with the MP36 or 45?
So with both systems are modular. And the MP36 system has universal amplifiers, so you can connect different sensors to the system. And with the MP200, 150, 160, etc., they have separate amplifier modules for different signals. So it's something that you have to add to the system, but not
Okay.
up front. It's because it's modular.
Okay, great. All right, so the poll results are 56% of people say yes, both, 21% yes, virtual reality, only 3% interested in augmented reality, and then the rest are not yet interested. Okay, back to you, Alex.
Okay, thank you. So before I move on to the next step, which will reference a virtual reality biofeedback scenario, I want to point out that we provide complete virtual reality lab systems. And what that means is, on one end, you have our AcqKnowledge software or the BIOPAC Student Lab software that can send over the network physiological signals and calculated metrics to the VR workstation. And then the VR workstation can actually also report back to our software event markers for eye tracking, when people grabbed and released objects, when stimuli were presented, and also using lab streaming layer, provide information about eye tracking, face tracking, positional data, and many more things. So these are just complete systems. And now I'll demonstrate a specific biofeedback application that's running in our in the VR system. And what that does is it provides heart rate variability biofeedback. So let me just set up a couple of windows here. So we'll fire up this window. And then also we'll open up a file. And this time I'll use playback mode, so I will not be connected myself. I have some data that was pre-recorded, and I'll just use that for the experiment. So on one side, I will place the physiological data, and so this will be on the left side, and then on the right side. Okay, so on the left side, we're gonna have the VR, and I can run this in an HMD. I have a MetaQuest Pro here, but I'm just gonna do desktop mode. And yeah, so I'll run this and I'll explain as we go along what's happening. So I can run this again in desktop mode or inside a variety of head-mounted displays. So I'm just going to run this in desktop mode, but could be in a Meta, HMD, could be in the new Vive Focus Vision, etc. Click OK. I can enter participant information if I want. And now we fire up the recording. What's happening here in this experiment is we're looking at a sphere that moves up and down as a function of changes to our heart rate variability. And I'll just pause the experiment here for a second, because yeah, I had something going wrong. So just a second. Let me make sure we're setting it up correctly. Okay. Latest version. Yep. Okay. Fire it up. Okay. All right. And I'll zoom in a little bit here. All right. So you can see the sphere moving up and down, and it goes higher when our heart rate variability increases, and it goes lower when it decreases. So it's supposed to help along with training the person to get into a specific heart rate variability state. The calculation happens the following way. AcqKnowledge is calculating the R2R interval, sending that data here to the VR engine, which then finds within each respiratory cycle the longest and the shortest R2R intervals, takes the difference of that, and computes essentially the HRV estimation based on that. Okay, that's a very, very basic description, but in part 2 of our biofeedback webinar, we'll go really in depth describing how this program works and how you can use it and similar ones in your research. As we can see, the VR engine controls completely the AcqKnowledge software, so now it stopped the recording. Also, it was sending markers back, saying what sort of calculations it has performed and at what time, so we can cross-check for accuracy. All right, so we can we'll cover that in more detail in the second part. So the complete virtual reality experiment generation systems that we provide, they have the hardware and software fully integrated with AcqKnowledge. There is a graphic user interface, experiment configuration capability. It's a very big library of templates, examples. We can do multi-user, and there's also data analysis capability. Earlier in the presentation, we mentioned functional near-infrared spectroscopy, and that can be used for biofeedback. We have two different kinds of systems, either VR or non-VR versions. Prefrontal cortex on the bottom and full head system on the top. Both of these systems can send the data in real time to the VR engine, and in this way provide feedback to the user. For example, provide feedback concerning cognitive workload, as in this air traffic control setup. Now, another example is if we're working with EDA or GSR, we can provide feedback to the user right within AcqKnowledge by using the gauge gain. So we can create a custom gauge so that if the skin conductance level of a participant is within that green area, which is lower skin conductance, means they're more relaxed, they will clearly know that. So they can try to do things like control breathing, etc., to relax. Also, we can perform feedback for skin conductance responses so that whenever skin conductance response occurs that crosses a certain threshold, a sound is played. So you get like a little beep every time you get a skin conductance response. We're not going to show this right now, but if you're interested, we can tell you how that works. We also can provide EEG biofeedback. We have devices for low density EEG, where we can place electrodes, including dry electrodes, in a higher density 24 or 32 channel system. All the data can be streamed over the network. We also have built into AcqKnowledge support for, and we provide this B-Alert device for EEG, which can calculate in real time, again, is channels in the software, engagement, confusion, distraction, drowsiness, workload, and stress. So a lot of information about the cognitive states of the participant. We can combine this with the new AI object tracking data from the eye tracking glasses that we have for elite training. So imagine you're an athlete preparing maybe to hit a golf club or to shoot an arrow, and we can provide information to the athlete about feedback about their cognitive state. Are they distracted at the moment? Are they really engaged? And also, are they looking at the right things? Are they looking at the target, etc.? So this is using the eye tracking glasses. We have this AI-powered real-time object detection, so we can know exactly what the participant is looking at. We can do this both in VR, by the way, using the eye tracking in VR, and also in the real world using the eye tracking glasses. So extremely compelling for providing biofeedback to athletes because you can give them information about cognitive state, and at the same time, are they really looking at what they're supposed to be looking? All right, so let's go for our last poll, after which we'll spend just 2 or 3 minutes providing an overview of the topics for the next part 2, which will be in about a month.
Okay, here we go with the last poll. Would you like to explain this, Alex, the workshops?
Yeah, so let me just see here. Yeah, so we teach quite a lot of workshops across the world, right? And we are just curious to see if you're interested in hosting a workshop or attending a workshop. We usually have these take place at the universities, and we invite people from nearby campuses to also join. And these can be one day, can be multiple day, and really this is like a really good learning opportunity. Recently, we both, Sanjay and I, have been doing quite a lot of workshops. So we're be very happy to meet you at one of these workshops.
Okay, great. And also, it's just you have a lot more time to do the training instead of an hour plus webinar like this, then you're hands-on with the equipment.
Yes, absolutely. The hands-on aspect is a very big point. So during those trainings, we can get people to start using the equipment and get some experience.
Okay. Well, thank you very much. I've ended the poll and back to you, Alex.
Thanks, Brenda. So very quickly now, because I know we're running late, but I wanted to give you a little bit of a teaser for part two. So one of the things we'll do in part two is we'll dissect this kind of example that I showed for heart rate variability biofeedback so that you know exactly how it works and how you can use it and create it yourself. We'll show an example for heart rate interoception. I know it's not exactly biofeedback, but it's a related topic so that you can play back sounds to the user either in sync or not in sync with their heartbeats. And we have an application note on our website which already addresses visualizing emotional state to the participant. So if we look at an axis of arousal, activation, deactivation, and then valence, pleasant, unpleasant, we can really easily visualize this in AcqKnowledge. But it can be a little bit still difficult to really understand and to really viscerally understand for the participant. So I will also show, and this is inspired by the Boyd's algorithm, which it's a swarming behavior algorithm. So we'll have a swarm of objects, like jellyfish, in 3D space. This is a VR setup surrounding the participant where these jellyfish change color depending on the valence. So imagine they can become red if you're aroused and blue if you are not. They can change the speed of their movement. It can change the color depending on the valence. It can change the speed of movement depending on the arousal. And also whether you're in approach or avoidant state, we can make them sort of converge or disperse. The idea being is that when we provide these forms of biofeedback in numbers and diagrams, do not really translate into an understanding of one's state, not always. And yeah, this is another way in which we can present at least emotional state information to the participant. We'll also show an example using VR for a rehabilitation task where the person must pass a virtual ring along the path without touching the path and providing feedback for performance as well as EMG. And we'll have an example for VR for meditation biofeedback. And that's all. And I hope that we see you about a month from now for part two.
Okay, great. Well, thank you. I'm going to go ahead and make myself the presenter. And Fraser's been doing a great job answering questions on the back end, so we're just going to skip the Q&A today because it's basically all been handled already. Wrong slide. Here's a slide about the workshops. We already had a poll about that, but if you're interested in filling out a form and submitting it to us, you could just scan that QR code or go to that URL and let us know you're interested, and that we'll send an email directly to your local representative. Also, I want to share with you and let you know about our new functionality called AcqKnowledge Cloud. This is a new and very easy way to manage your study data. It's a single secure web interface and it's completely integrated with AcqKnowledge version 6 as an add-on license. You can manage all of your physiological data, experimental templates, video files, questionnaires, and stimulus presentation files, and sync it with AcqKnowledge software version 6. You can get a 30-day free trial of AcqKnowledge Cloud when you upgrade to V6. So scan that QR code and learn a little bit more about it, and then contact your representative to figure out how to get that free trial. And I did want to show you, here's the website for that, the web page for that. If you scroll down to any page of our website, you can click to this local sales section here and you click that button, it'll email If you fill out this form, it will email your local representative. Mine is Amy because I'm in California, but yours will be yours wherever you're located in the world. Also, I just wanted to show you really quickly that our webinars page hosts all of our webinars, and you can watch them on demand at your convenience. And then our next webinars, we have one scheduled for May 22nd, and that is an advanced wearables for research, capturing ECG, heart rate variability with a research ring. And then the follow-up webinar to today's webinar for biofeedback is June 5th. All right, today's webinar was recorded. We'll email you a link of today's recording and the slides, and if there's a Q&A document, we'll send that as well. I just want to take a moment to thank our presenters. Thank you guys so much. I know it takes a lot of work to put these presentations together, and I appreciate your time on that. When the audience members close the webinar window, you'll see a survey. Please complete that so we have your feedback and ideas. You may visit biopac.com for additional references, including screencasts on specific features, analysis tools, application notes with step-by-step instructions, and of course, information on upcoming webinars and events. We were just at the American Physiological Summit this last week, and we have several events coming up here in May and early June. We'll be at ACSM, HAPS, and APS, the other APS, American Psychological Society. All right. Anything else before we conclude, speakers?
Since you mentioned the ring, I just want to show it right here. Right, so this is the ring that we were talking about, and especially for biofeedback, since it connects directly to the AcqKnowledge software, it's very cool. So it will be worthwhile if you join for that particular webinar. Thanks.
Okay, well, thank you again, Alex and Sanjay. Really appreciate your time. Thank you, audience members, for participating, and we'll see you at the next webinar. Have a great rest of your day. Bye, everyone.
Thanks. Bye, everyone.
Bye.